given a set x, y, z, where we call x and its complement, and similarly y and its complement, and z and its complement, literals, a minterm is the product of n distinct literals. So for example, we have n elements in our set here. So an example is the complement of x and y and z being a minterm. X and y and the complement of z is another example, and so on. So note that order doesn't matter, so equally valid is x and the complement of z and y. So x and y is not a minterm, and neither is x and y and the complement of x. So we can't repeat x in the minterm expression. Now a disjunctive normal form is a Boolean sum of distinct minterms. So for example, x and y and the complement of z, or the complement of x and y and z, or x and y and z, is a disjunctive normal form in the set x, y, z. Now given a Boolean expression, E1, there are two ways to find a disjunctive normal form, E2, that's equivalent to E1. And one of those is using a truth table, and the other is using algebraic manipulation. So for example, if we have a Boolean expression E1 being x and y, or x and y and z, so using algebra, we can write the first term using an identity property, z or its complement, because it gives 1 and doesn't alter this term. And then we have or x and y and z. And now we can use a distributive property. So we have x and y and z, or x and y and the complement of z, or x and y and z. And we can use a commutative property. So we can write x and y and the complement of z, or x and y and z, or x and y and z. And then using the associative property, we can do this comparison first. So this evaluates the x, y, z, or x and y and the complement of z. So this here is a disjunctive normal form, which is equivalent to our original Boolean expression. And I encourage you to construct a truth table and evaluate these expressions, and you'll see that they're equivalent.